Hello, welcome to GRC 605, Unit 6, Applying Regression to Survey Data. My name is Gustav Muketer. So for this unit, I will be showing you how to conduct regression analysis. So how to apply regression to provided survey data. So let's move quick here to our agenda for today. For our agenda today, first we'll have a quick introduction. Secondly, we'll get a data analysis summary, and then we'll move to linear regression samples. Next, we'll take a look at key annotated bibliographies selected from our course unit, and we'll summarize these three articles as well. And then you will see key takeaways related to our regression analysis, and I'll give a chance for anyone to ask questions, and I'll provide answers to these questions. So, our introduction here first. What is regression? So regression is a statistical method used to measure the strength of linearity between variables. So if we have two variables in question, the regression analysis helps us to establish that strength of the linear relationship between the two variables under investigation. So regression here ranges between -1 and +1. Another very important thing here to note is the fact that the closer you move to -1, the stronger the negative linear relationship between the variables under question. And the closer to +1 or absolute 1 value, the stronger the positive relationship between the variables in question. And the closer to 0, the weaker the positive linear relationship between variables. Next point, in correlation, the two variables are treated as equals. And in regression, one variable is considered the independent variable or the predictor variable, which is also known as the x variable. By x variable here, what I mean is this is the variable that rests on the x-axis. And the other dependent variable or the outcome variable is the y variable that also rests on the y-axis of our coordinates. During this study, we'll use the 95% confidence interval for PSPP analysis. So just take note of that. Our next slide here tells us about the data analysis summary. We found two significant results and one non-significant result. So the first significant result here emanated from our savings versus income observation, and the second came from stocks versus savings. The non-significant result was seen in our income versus debt analysis. Our next slide here, we explore the first significant result that we found from our study. What is our hypothesis here? The null hypothesis is saying that the regression coefficient or beta is equal to 0, while the alternative hypothesis is saying that the regression coefficient is non-zero or not equal to 0. What did we find? So a simple linear regression was conducted to determine whether we can predict an individual's savings by knowing their income. So we used PSPP, as you can see on the slide, to conduct this analysis. A statistical significant regression emerged with our beta equal to 0.91, our R squared 0.82, and our p-value 0.000. Thus, the test rejected the null hypothesis and predicted savings. So our equation here is saying that savings is equal to 0.91 times our income minus the absolute 203.47. So if we know an individual's income, we can predict that individual's savings by plugging the income value and multiplying by 0.91 and subtracting 203.47 to get that savings of the individual. That's pretty clear, straightforward. So savings is predicted to increase as income increases. We can see that from our beta values, very strong, 0.91. Further, 95% confidence interval, 0.09 and 0.11 does not contain the zero value, hence providing or lending further support to our prediction. Next significant result here was related to stocks versus savings. Hypothesis here again, our null is saying the regression coefficient is 0, and our alternative is saying that our regression coefficient is not equal to 0. A simple linear regression was conducted here again to determine whether an individual's portfolio can be predicted by knowing their savings. A statistically significant regression emerged here as well, with our beta 0.28 way less than our initial case. Our R squared was 0.08 and we had the same p-value here, 0.000. Thus, the test rejected the null hypothesis and predicted stocks. So if we know an individual's savings, we can predict the portfolio of that individual by plugging the savings value, multiplying that by 0.28 and adding 1006.73 to get the individual's portfolio. Again, stocks are predicted to increase as savings increase. We see our beta value is positive, and at 95% confidence interval did not contain the zero value as well, hence lending additional support to this beautiful prediction. We'll move to the third test here, which is the non-significant result test, which is based on our income versus debt observation. What is our null hypothesis? The regression coefficient beta is equal to 0. Our alternative hypothesis saying that the regression coefficient beta is not 0 or not equal to 0. We conducted a simple linear regression using our beautiful PSPP tool here again to determine whether we can predict an individual's debt by knowing their income. Here we didn't see any significant regression, with our beta here coming up to be negative 0.05, our R squared 0.00, our p-value 0.535, which is way greater than our alpha. Hence, we had to reject this hypothesis, and we didn't see any significant result in this case. Now we'll take a look at our annotated bibliography. The first article here. In this article, we saw how the chi-square test of independence was used to demonstrate how independent two variables can be. So we have a beautiful overview here from a great scholar and researcher. So the content here was very descriptive, was very simple, where the author was trying to investigate whether there was a relationship between vaccination and the number of employees who contracted the disease pneumonia. As an experienced researcher, the author is highly aware. She incorporated all the assumptions and limitations inherent in the experiment, and also the ethical implications of the experimental research tactics used to conduct this research. Another thing here is the reflection in terms of all these areas. The reflection was great in terms of all these research components. The author is equally very impending about the methods, and also supplements her experiences with very clear and easy to understand examples. This article has a well summarized structure It's highly descriptive, and results have been highly and adequately interpreted. We see the link to this article right next to the last line. The second article here came from a social research methods network. So the article explores the correlation subject matter. So two variables here, height and self-esteem, which are great variables. So it's a great research, by the way, were used to demonstrate the concept of correlation. So how related, how does your self-esteem correlate with your height? So it doesn't mean that a short person has a lower self-esteem than a tall person. That's what this study was about exploring. So this experiment clearly used a sample of 20 persons with a step-by-step approach to explain the correlation. We saw histograms, we saw very good graphical representations used to provide a better understanding of the data on the study. This article also used a simplistic approach to demonstrate the calculation of correlation coefficient. So we saw how they used the manual method to show how to calculate the correlation coefficient, which was very, very important for me during this lesson. The authors of this article were also able to demonstrate how to set up and to test a correlation hypothesis. So the crafting and the testing of correlation hypothesis was adequately covered. And finally, another observation here is the author actually summarized the investigation process related to multi-variable situations. So we saw the use of the correlation matrix and how you can have 10 variables, but we can establish the correlation, over 100 correlations between those 10 variables. We also have the link here. Let's move to our final article, which is the third article. This article is by Minitab. It also provided a vivid and very clear understanding of the p-value, alpha, when and how to make use of this. The author provided valuable insight on how to craft a hypothesis like the previous articles. We also saw how to identify and to avoid statistical errors type 1 and 2 in hypothesis testing. The interpretation of the p-value also provided a very strong understanding of the decision rule framework in hypothesis testing. When are you supposed to reject your null hypothesis, and when are you supposed to accept your null hypothesis based on the values of the p and levels of significance or alpha? We saw the use of descriptive and pictorial statistical methods here in the elucidation process and clarity provision on the above subject matter. The author equally incorporated the assumptions and the limitations in this study, providing room for further research on this topic. We also have the link here below. How do we summarize these three articles? First, here, all three articles provided very objective and credible examples that facilitated the understanding of the subject matter. Secondly, I found these three articles very helpful because all three made use of descriptive methods, which actually simplified all the steps involved in hypothesis testing. Also, they provided a very valuable insight on how to craft a hypothesis test and how to make use of the p-value and levels of significance in order to arrive at an optimal decision after analyzing your data. Again, I was able to understand how to conduct manual calculations on key coefficients like the coefficient of correlation manually by hand after assimilating information from the articles. Next, what are key takeaways here? The first takeaway here is that regressions help to determine the causal relationship between two variables. We can also use the correlation matrix to have a quick picture of numerous correlations existing between more than two variables. Next, regression also helps in making predictions by using the regression equation like we saw with our samples earlier. Finally, it is imperative to identify the dependent variable, which is the y variable, that needs to be predicted, and also the independent variable x before executing our PSPP analysis. Thanks again for watching this session, and if you have any questions, feel free to email me the questions and I'll provide you an answer to your question as soon as I get your email. Thank you once again, and I wish you all a blessed night.